then you can go on till, you know, you can put here less than 80, and then you would have 8 elements as well. Okay, so we do I plus plus or plus I plus plus I, excuse me, and then you go inside the for loop, and inside the for loop what you're gonna do is you're gonna have here the array, or you can say ptr I. Okay, so this is basically for index, or you can say for array. Okay, so if you don't have any array concept yet, so do not worry. Just remember that this thing is used for indexing, and index always starts from 0, 0 1 2 3, okay, something like that. So I think we have a separate video of arrays on our channel, so make sure that you search in the bar about arrays, or I would put in the link in the description if I you know, figure out if I have any array video. If I didn't figure it out on our channel, then I would create a special array video in future, okay, and then I would associate the link, so stay tuned for that as well. Okay, so I would write here equal, and then obviously we want to move one index forward because we want to save each element on, you know, on one index. For single index we want to save a single element. Okay, so we need to move on to the next index as the for loop runs. Okay, so once we have you know, gone through this for loop, after that what we are going to do is that we are going to write here a printf statement, which would basically print out the elements. So would write here a printf, and again we are going to need for loop to print out these elements that we have inserted into the memory blocks. Okay, so we can say that inserted elements, or we can say inserted 8 elements in the block are as follows. Okay, then we put slash n to go to the next line, and then what we are going to do is that we are going to write a for loop, and we are going to extract everything from that memory. So write here printf, and oh, excuse me, for loop actually. We write here for, and then we write here I, integer I, excuse me, which we have to initialize again, because here we have initialized inside this for loop, so this was just for it. So after that we cannot use this variable because it was initialized locally. So there is another concept in C of local and global variables that we would also discuss in future. Okay, so I is equal to 0, and then we just put a semicolon here, and after that we just write here I equals less than n. Okay, the same for statement, but after that we just have inside of it the print statement in order to print the elements that we have allocated to a specific memory. Okay, so now in here what we are gonna write, we're gonna write here printf statement, printf, and inside of here we're gonna write %d, which stands which would basically print out the integer, and then we're gonna write here pointer. Okay, then we're gonna extract the elements from the memory using pointer actually. Okay, so we put this thing here, and I think we are done here. Okay, so this is our code that we have written. All right, so don't worry for the other memory allocation functions, memory allocation family functions. We're not going to rewrite the whole code, we are just gonna change this one line. Okay, so we just save this, and let's go ahead and let's try to run it if this thing really works. And here we're gonna write num instead of n, and now we save it, and we go ahead and we try to run our program. So here we'd write gcc, and then we'd write here the program file name, and then we write here -o, and then we would write here the binary file name, which is tst. We hit enter, and you can see that it has not given us any error, so it has generated the binary file for us. So when we hit enter, you can see that we have 8 elements to allocate memory to. Memory allocation has been successful. Inserted 8 elements in the block are as follows. So 1 2 3 4 5 6 7 8. Now for the other function, which is contiguous allocation, or the CALLOC, for that the the everything would remain the same, just a few things would change. Okay, so instead of the multiplication sign for general syntax, let me go here. If we talk about the general syntax, the cast type would remain the same. Here instead of MALLOC, we'd have CALLOC, and then instead of byte size and instead of multiplication, what we're gonna do, that we're gonna have byte size here, and then we're gonna have a comma, and then we're gonna have the element size as well. Okay, so recently we had just the byte size. So if we just would have written here size of int, then obviously it would have just assumed that the byte size is just for single memory allocation. So it's of 4 byte. Okay, so one block is of 4 bytes, so it would just have assumed that only one element memory allocation is required. Okay, but we did what? We multiplied it with a number, right, which was 8. So we multiplied it with 8, so now the memory allocation was for 8 elements. Okay, instead of having this, we just have a comma here. Okay, and yeah, everything would remain the same. So now we save it, and we go ahead and we try to run our program. Okay, let me just clear it. So we write here gcc c program .c and then -o. Then we have here the file name, which is tst. We hit enter, and it doesn't give us any error, so we would write here /tst. So you can see that it says memory allocation has been successful. Okay, but here we have to write here memory allocation has been successful using, you can write here using CALLOC, contiguous allocation. Okay, so yeah, that would give you the output. Okay, so now if you want to deallocate, you have to use this free method. Okay, so let's say we go to here where we have code, and if we would have used these both both functions, contiguous allocation and the memory allocation, then in that case, if you want to use it simultaneously in one code, then you have to have 2 pointers, but we just have 1 pointer here, so we just try to free the one that we have here. So in order to free the memory, what you have to do is you just have to write the free the pointer. Okay, so you just have to add one single line. Okay, so here till here we know that let me just comment these lines, because these are the lines that we don't need. So in order to comment multiple lines in C, you do this. Okay, static and then the slash. Okay, so now these multiple lines have been commented, and if you want to comment a single line, then this double slash would work. So if you want to free the pointer, what you have to do is that you just have to write here free, and then you need to have here brackets, and inside these brackets you're just gonna write here the pointer that you want to free. So you just write here ptr, and now the memory has been deallocated successfully. Okay, so we just write here that CALLOC, or contiguous memory has been freed or deallocated. Okay, so we save this, we go back to our terminal and we try to run our C program, and we write here tst, we hit enter, and yes, we have that file, the binary file. We hit enter and you can see that we have 8 elements to allocate the memory to. Memory allocation has been successful using CALOC. Then we have CALLOC, or contagious memory has been freed or deallocated. Okay, so first we allocated the memory and then we have deallocated using the free function. Okay, so the next thing that we are gonna do is that we are going to reallocate the memory. So in order to do that, what we have to have is that let me just remove this thing from here, and the idea is that we have not been writing anything inside the else block, but technically you should write everything inside the else block. But if you're writing outside the else block, that is totally fine as well, because the only way the cursor is gonna move ahead if it satisfies the if statement. Okay, so you can write this for loop inside this else block as well, it would work the same. So now let's say that if we have allocated the memory as let's say we have given it a size of 8 and then we need to give it a size of 16, let's say. So how do we do that? In that case, what we would do, that we would reallocate and we would give it like a bigger size. Okay, so in order to do that, what you have to do is that you just have to use the function of reallocation, which just have a general syntax of something like this, ptr equals, then you don't have to have a cost type here, you just write here, let me just write it here for you. So let me just go back and let me just write here for you. So I would just write here the general syntax of that first. So ptr equals, then you write here reallocate, you put in brackets here, then you write here ptr as the first argument, and then you write here new size as the second argument, whatever the size is. Okay, doesn't matter. So now let's go ahead and let's use this reallocation function. So we write here ptr equals reallocate, and then we write here ptr and then the new size would be, let's say 16 multiplied by size of int. Okay, so let's say that we have here the memory allocation function, which is malloc, and we have here number star size of. Okay, so now once we have done that, we put a semicolon here, and after that we can just print here printf, and we can say memory has been reallocated. Okay, and then we put a semicolon here. All right, so after that you can write here, you can put this 16 inside another variable, and then you can have these for loops printed out here, pasted here, and then you can make just simple change in this condition here, and then you can have 16 elements go directly into the new allocated memory, and then you'd see the result. Okay, so we just save it and we just show you the output, and then we just move on. Okay, so it go on, we write here gcc, then we have C program -o tst, then after that once we have executed it, hasn't given us any error, and now you can see that it says memory has been reallocated. Okay, and after that you can have for loop, and maybe has it printed out till 16, from 1 to 16. Okay, it would print out easily. So I hope you have got the point. So we have done these 4 functions. Okay, so the next topic is users and groups. All right, so the